Until unless you don't know the problem properly, you cannot derive to the solution properly. Okay, so first and foremost thing what we have is define the problem. Agent have a ability to perceive the environment. He has to observe the environment, he has to learn from the environment, he has to understand the environment. That is called as perception. Whatever the predefined rules we have for the agent, depending on that, it is going to give the action back to the environment. Hello everyone, welcome to the second session on the Unit 1 for the Artificial Intelligence and Application for the 6th semester B.Ca student. Myself, Indu J, Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. We'll continue with the introduction. As a Unit 1, we have already discussed what is agent, what is intelligent agent, what is environment. Now we'll take our discussion for further. We'll be discussing agent-based programming. What is agent-based programming? As we discussed in the previous classes, agent has to observe the environment, has to perceive, has to observe everything and understand it. Then he has to respond back to the environment. How this response back is given to the environment is purely depend on this agent-based programming. We program the agent such that he should perceive, accurate, and then with the help of the efforters, he should respond back to the environment. That is our agent-based program. What agent-based program is? The agent-based program or agent-based model system behavior results from the individual behavior and the collective behavior of the agent. In a single environment, a single agent can work or a multiple agent together can work. So it can be the combination or the result of behavior of the single agent, or it can be the collaborative result of behavior of different agent. How we are going to design this program? Agent is equal to architecture plus program. Architecture on which he is working for, agent is working, and for particular scenario or the situation, how he has to respond back, that is given with the program. Okay, then the agent program is nothing but a function which map the percept to its action. What is the program we are writing it for? We are writing the program to map the perception. Perception is what? Observation to action. To its action. Observe and then act according to the situation. That is nothing but agent-based programming. Now let us see what are the key components we have in agent-based modeling. So whenever we say key components, definitely we are talking about the agent. Then the agent must be there. Where agent is working? Agent is working on particular environment. So environment must be the basic key components what we are supposed to have. You know who is the agent, right? What is the agents are the individual entity that make up the system being modeled. Depend on the agents, we are modeling the system, or it is an individual entity we can say. What all agents should have? Agent should have its attributes, behavior and ability to interact with each other and the environment. Most and the important thing is agent has to work on the environment, right? So that is nothing but the second component of the agent-based modeling. Environment is what? Environment is the space or the context in which agent operates, on which agent is operating or in which agent is working. That is called as a environment. It includes the physical space, resources and any other relevant factors. What all we include in the environment? It may be the physical space where agent is working, or it may be the resources what agent is using to work in the environment, and some other relevant factors we can add up to the environment. Apart from these two, some more key components what we have is behavior. how agent is going to behave for that particular environment. For example, if you take a behavior of the salesperson, when he's approaching a lady, his approach is different. When he's approaching a gents, the approach is different. He should know what is a key factor that the person is going to affect. A lady is going to affect, or a male person is going to affect. So behavior is also one important key factor what we have. Agent exhibits a behavior that dedicate how they interact with the environment. What exactly the behavior give? Behavior gives the interaction with the environment or other agents. So what may be the behaviors? Behaviors may be the movement, how we are moving in that particular environment and how we are having the connection with the other agents. And decision making depends on the percept, understand and make a decision, act on that, how we are communicating with the other agent and how we are adopting to that particular environment. That is called as behavior of the agent. Then once we know what is the behavior of the agent, depend on the environment and agent behavior, we should set some rules. That comes up one more key factor as a rules. Rules define the constraint and the guidelines that grooms the agent behavior. So to take a decision, there must be some rules on which base agent is going to take a decision. So that is what the constraint or the guideline for the agent's behavior. These rules may explicit instruction. These rules may be given with the explicit instruction way or may emerge from the interaction between the agent. May emerge when the agents are interacting between each other, one new idea will come. So that may be also a rule. So next, interaction. What is interaction? Having an interaction with some other agent, having a communication with some other agent, how one agent is going to collaborate with the other agent in the same environment to get the proper goal or proper output. So that is nothing but the interaction. This can involve the direct communication, cooperations, competitions and other forms of influences. Like for example, you look at the YouTube influencers and you will get influenced by them and you start trying copying them, right? Similarly, one agent can influence by other agent. So how that agent is behaving, he observes the agent's behavior and then he try to imbibe that behavior with himself. That all can be done. So this all comes under what? Interaction is a one more key components in agent based programming. Apart from that, as we just discussed, emerging when two agents are interacting with each other, one new idea will emerge up. So that is not programmed, not given it as an instruction. So there is no instruction for the emergence component. It will be come with the previous experience or when we are interacting with the other agents. That refers to the phenomena where the complex of often unexpected system level patterns or the behavior rises from the interaction of the simple agents. When we are interacting with the agents, some new ideas will emerge. That is also we can consider the key components. Then most important, time. How much time a agent require to action or to respond back to the environment once environment is studied. That is nothing but time. What is time? How much time a agent required to respond back, to act on the environment. The agent operates over the time and the temporal dimension is crucial in understanding how the system evolves. Time steps represent the discretion interval during which agent makes a decision. How fast agent can make the decision, that is calculated using the help of time intervals. So these are all the key components what we have in the agent based modeling. The steps in the agent based modeling, how to create any agent based modeling. So first and foremost thing what we have to know, we have to define the problem for what we are finding a solution for. Unless you don't know the problem properly, you cannot derive to the solution properly. Okay, so first and foremost thing what we have is define the problem. After defining the problem, I should know what all the complexity we have and what all the elements we need to solve that particular problem. Then we are going to define a agent and the environment to solve this particular problem. So specifying which agent will work on this problem, on which environment the agent is going to work on this particular problem. Then after specifying agent and in the environment, next what we have, model behavior and rules. Now we know what is problem, we have defined the problem, and we have some strategy to find the solution for the problem, right? We know who is going to work on that problem, what agent is going to work, and which environment we are going to work, that is being specified. Now we should set some behavior. Agent should behave with environment, how the agent should behave with the environment, and what all the set of rules we have to behave the agent properly. So we have to model the behavior as well as the rules. So specify the behavior of the agent and then the rules that groom their interactions. This may involve coding decisions, making process, coding decision making process, movement rules and other behavior of the agents. Then 3 is done. We know what is the problem, we know who is going to work on that and where is going to work on it. We have some set of behavior and some set of rule to work on the particular problem. Next what we have is implementation of the model. Once we have developed some set of rules and the behavior, those rules and the behavior should be implemented on particular model. So use a programming language or a dedicated agent based modeling platform to implement those popular programming based language are what we are using, Python, Java and NetLogo. Using these programming based language, we are going to write a program for agent based modeling. After implementing the model, that has to be run with the simulation. We are not directly implementing it on the real world. We are using the simulation method to check whether the given output is proper or not. Can it be implemented in the real world? Using the simulations, we are going to implement and use those implemented model in the simulation. Next, analyze the results. Once we have done with the simulation, we have to analyze the results for the different cases. All the cases result will be different. So after analyzing the results, we should validate and we should redefine if anything is missing there. So we should validate the result and we should redefine or refine the result for the optimal solution of the problem, right? So these are all the steps how we are going to create a agent based modeling or agent based program. So what would be the structure of the agent? Once we have to create an agent, we should know what a structure of agent should be. So in the structure of the agent, we'll have a 12 components. One is attribute. What is attribute? The property of the object is called as attribute. Hence, we are using agent as one device. The property of the device will be called as attribute here. Agent have an attribute that defines their character or the state. How we are going to define the attributes? Attributes are the character. For example, if this is a pen, so what all the attribute have? Pen should write. Pen should have this much of length, this much of width, and we should have a grip to hold. Okay, this much of this is a color of the ink, what I'm going to put. What is the refilling? The pen is either the refilling or use and throw pen. So these are all the character of the pen, right? Color of the pen. So those characters are called as attribute here. Next, once we have defined the characters or attributes, then we have to percept. We have to have a ability to perceive. The agent should have a ability to percept. Agent have a ability to perceive the environment. He has to observe the environment. He has to learn from the environment. He has to understand the environment. That is called as perception. This involves using the sensors. How he is going to do understand the environment with the help of the sensors or the mechanism of gathered information about the state of the art which is surrounded by the environment. So clear? One is an attribute, another is a perception a agent must have. And agent must have a memory. Whatever is percepting, whatever is observing in the environment, that has to be stored for the further use. So it has to have a memory. Agent often have a memory or the internal state that allows them to store the information about its past experience. Whatever they have learned from the past experience, that has to be stored and that can be used for the taking further actions. So it is mandatory that it should have a memory. Agent should have a memory. Then decision making. Once we have a perception plus we have a memory. Depending on these two aspects is going to make a decision. What I have to do? If this is my scenario, for this scenario I have to react. So that is going to tell by decision making. Agent possess a decision making mechanism that determines how they will act based on their current perception, and the internal state. Internal state is nothing but the memory. So based on these two factors, he is going to do the decision whether to act or not to act. And then we should have a agent should have the behavior. We have already discussed what is a behavior. It should have a movement, communication, cooperation and coordination and adoption for the environment as well as for the other agents also. Then it should have an interaction. We have discussed the interaction also. What is interaction? It should interact with the other agents in the environment, interact with the environment and the other agent. Interaction can be direct or it can be indirect. What is the example of the direct interaction? That is a physical contact. For the indirect interaction, you have a composition or the resources that what we are using. The rules, governance, interactions are the essential part of the agent structure. Once we have a behavior, we should define the rules also, rules of the agent behavior. That is also an important part of agent structure. Apart from this, what else we have is action and learning. Once we are making a decision, for that decision agent has to stick on to that decision, and according to made a decision, he has to act. That is nothing but action. Agent takes the action based on the decision making process. Action represent the physical or logical operation. Action can be a physical operation or it can be a logical operation. Then what we have is learning. Once we done the action, what is the outcome of that? Is machine is learning by itself by looking at the outcome of what the action has done. In some cases, agent has the ability to learns from experience. Learning mechanism can include the reinforcement learning, supervised learning and unsupervised learning, other type of learning technique using that the machine can or the agent can learn by itself. Apart from that, what we have is communication. So in the structure of agent, one more component is a communication. Agent may communicate with each other to share the information, coordination activity. Communication can be essential with the multi-agent system. When we have a multi-agent system working on the same environment, communication is an essential part of it. Then of course, what we are designing the agent for? We are designing the agent for to reach the goal, right? So this is one of the structure of while we are designing the agent. Agent often have the goals or the objective they aim to achieve. Goal guides their decision making and the action, influencing how the agent prioritize their behavior, right? So to reach that particular goal, how we have to use the decision making, what action we have to take and what influences we have to take from the other agents, and which rule has to be prioritized first, which rule has to be executed first. These are all will be taken care, and these are all the components of the structure of agents. Then identity. Agent should have its own identity. Agent can have a unique identity or identifier to distinguish them from the other agent. We cannot say Suma. Suma is, how many Sumas are there? So to distinguish one Suma with other Suma, will be having initials or will be having roll numbers. So similarly, each agent should have its own identity to separate or to distinguish the agent from the other agents. Then atomicity. Atomicity, agents are typically autonomous, meaning they have a degree of independence in the decision making and action of execution. Agents are free to take any kind of decision. That is nothing but the atomacy. Okay, these are all of a structure of agent. So these are the points what we have discussed: attribute, perception, memory, decision making, behavior, interaction, action, learning, communication, goal, identity and atomacy. Okay, so these are all the structure of agents. Now we'll move on to the types of agents. We have basically 4 types of agent. One is simple reflex agent, model based agent, goal based agent and utility based agent. What we are doing in the simple reflex agent, these agents operate based on the set of predefined rules. How it's going to work? At the particular instant, what is the condition we have given, depending on that condition it's going to give the action. So that is called as simple reflect agent. Simply it will reflect or respond to the current situation. Okay, then come with model based agent. These model based agents work with the internal state or the model words, and it will maintain the current state, compare with the previous history and act according to that. Okay, that is model based reflex. Clear? In the model base, for the current scenario, what is observing, what is happening, it observes that what is happening, it compares the same situation with the history of the previous history, then it will take the action. So this is called as model based reflection. We'll discuss each model in detail. Okay. And then the third type of agent is goal-based agent. Here the main objective is to reach the goal. So what we are determining here, how far to reach the goal. So for example, you have to travel for 3 kilometers, you have traveled for 1 kilometer. You are 2 kilometers far to reach the goal. So that is given by goal-based agent. Okay, what we are doing? The goal-based agent, they specify the objective or goal to achieve. They evaluate the action based on their ability to bring the system from the current state to very closer to the goal. Then what we have is utility agents. Utility-based agents make a decision by evaluating the utility or describability of the different outcomes. So we have a different outcomes here, which is the optimal outcome. It has to check. It has to utilize the optimal solution. That is called as utility-based agent. Let us see each one of them in detail. Apart from these 4, we have another type of agents also, like learning agent, relational agents and adaptive agents. So that is not there for your syllabus. So we'll concentrate mostly on these 4 type of reflex agents. So they will concentrate on these 4 type of reflex agent. First one what we have is simple reflex agent. What simple reflex agent? Simple reflex agent ignores the rest of the percept history. It does not act on the history and it act only the basis of the current perception and percepts. How it does it? What happening right now? Live in a moment, what you say. So in the moment, it acts in the moment. That is called as current perception. The agent function is based on the condition, action and then rule. Whatever the predefined rules we have for the agent, depending on that, it is going to give the action back to the environment. If the condition is true, then the action is taken. If condition is false, the action is not taken. It's as simple as that. This agent function will only be used when we have fully observed environment. When we can use a simple reflex agent, we can use a simple reflex agent only when we have fully observed environment. This what is fully observed environment? Different types of environment we have discussed in the session 1. Kindly go through with the link. Then if the simple reflex agent operating in the partial observation environment, then what happen? It will enter into infinite loop. What is fully observed? Where we are knowing all the scenarios, all the content of the environment. In the partially, we know only the partial content of the environment. If I am trying to implement this simple reflex agent in the partial environment, it may turn to infinite loop. But to implement simple reflex agent with the full observed environment is very easy and very good to implement simple reflex agent with the fully observed environment. Let us see. I can give you an example for simple reflex agent is what we can say, room temperature. You have your room is now, summer is going on, right? So if the degree of room temperature goes more than 34 degrees Celsius, I am creating one agent, temperature sensor, that will sense the environment of the room and it will act accordingly. If it goes more than 35 degrees centigrade, switch on the AC. So what is the action here? What is the perception here? Perception is sensing the environment, sensing the temperature of the environment. Once it senses and observes and it sees the temperature is moving more than 34 degrees Celsius, then what is the action it's going to take? It will switch on the AC, right, in the temperature. Irrespective of that, whether someone is there in the room or not, whenever someone is there, then only AC will be helpful, right? If not, simply it will make the room cool. No use in that. That comes into the model base again. So in the simple reflex, what is the instant? Instant is more than 34 degrees Celsius, switch on the AC. So it doesn't look into any other criteria. Simply it will switch on the AC. So here you can see this is the environment what we have. I have just now told you what is the environment. Room is the environment, right? So what is a sensor? Temperature sensor is a sensor what is accordingly, and it will percept, it will observe the environment. What is a perception? If it is greater than 34 degree centigrade, that's a perception what we have given to the agent, and the sensor will act. What is the word is right now? Right now is check with this condition whether it is greater than. If it is true, the condition is true, it will take the action. If the condition is false, it is not take the action. This is a condition. If the condition is true, it will take the action. If the condition is false, it does not take the action. What action should I do now? What action you should do? Switch on AC. What is action we are doing? Once that it's satisfying this condition, switch on AC. So once its action is done, decision is done, actuator is going to do that action and respond back to the environment. So this is what the simple reflex agent. It will act in the current situation. Next, moving to the problems what we have in a simple reflex agents. The problem, it's very limited intelligence. Why limited intelligence? It does not check whether someone is there in the room or not to take that AC, to feel that cold, right? So simply it acts on the instance. It does not have a intelligence. The intelligence of this agent is very limited. No knowledge of no predictional part of the state. It don't have a prior knowledge to implement on that particular current situation. Usually go big to generate and store. It will take a large amount of the space to generate as well as to store the result back to the environment. If these occurs, any changes in the environment, then the collections of the rules need to be updated. If the room environment is changed, I don't want to 34 degree, I want to change it to 28 degree, you have to change that. Where I have to change? We have to change that in the rules section. Rule has to be keep on updating for the simple reflex agent. So these are some of the problems what we have in the simple reflex agent. Then moving on to the model based reflex agent. How model based reflex agent works? It works by finding the rule whose condition matches the current situation. It compares the current situation with the previous history. It agents handle the partially observed environment. This model based reflex agent can also handle the partially observed environment. The agent has to keep the track of internal state. Internal state is nothing but what? Memory, which is adjusted by each percept, and then depends on that the percept the previous history. Updating the state requires the information about something. You want to update the particular rules in the model based session. So what you have to do? Have to check how word evolved independently from the agent, whether the given environment is independent from the agent or not, and then we have to check how do the agent action affects the word. What action taken by the agent, how does it affect? So this is a model based agent. What the example I can give for the model based agent is driverless car. Okay, it is a partially observed environment. Why partially observed environment? You know what is there in your car. The agent know how to give accelerator, how to give clutch or brake, how to drive, how to drive the steerings. So these are all the known factor. What he don't know partially means something he know and something he don't know. What the agent don't know, how the road traffic will be. Road is highway or road has some humps, road is digged, the road construction is going on. So these are all some of the things that it does not know. But still, if that does not know, we can implement the model based reflect agent. Whatever the room temperature we have taken here, environment we have, who is going to perceive the environment? Agent is going to perceive the environment with the help of sensors. Once he perceives the environment, he has to check what is the word look like. So it is a current situation. What is this? Current situation. So this current situation is compared with the previous history. This all comes under previous history. So this current situation is compared with the previous state, how the word was evolved for this particular situation previously, what action is taken. So depending on it, compare this with the this, and then it will take the action. What action should I do? That is purely depend on the condition what we are going to give, or the set of rules on that what we are going to take the action. Again, once we have made the decision, that the decision has to be come in the form of action. So who is going to do that? Actuators is going to give the action back to the environment. So this is all about model based reflex agent. Next, what we have is goal based reflect agent. Here, as we have discussed already, this particularly mostly concentrate on the goal. Okay, then this kind of agents take a decision based on how far they are currently from the goal. So from here the agent is there, he has to reach this particular goal. So how many steps he has to take? He has to take some n number of steps. So now agent is here. So how far is from the goal with the current situation? So that is described by goal based agent. This ever action is intended to reduce the distance of the goal. This agent works only to reduce. From here he has to move here, from here he has to move here, from here he has to reduce the distance between the goal and then the agent. It will works on that. This allows the agent a way to choose among the multiple possibilities. I can go like this one by one, I can go like this, skipping the two counts like that. It will provide you the multiple probability to reach the goal. The knowledge that supports is decision is represented explicitly can be modified. Whatever the knowledge we have given for the previously, that can be modeled. So what exactly the goal based is doing? Goal based works with the current situation plus history of previous scenario. So including both the aspects of simple reflex and the model reflex is going to make one decision. It's going to make one decision, and according to the decision is going to do the action. So this is how the simple goal-based agent is going to work. The goal-based agent behaviors can easily be changeable. We can change the behavior of the goal-based agent easily. So here we can see environment we have, agent we have, this is the agent, this is the environment, agent perceive the environment with the help of sensors, right? So it is in the current situation, it will go back to the state in the previous history. Once it go back to the state in the previous history, that will be given back to the current situation, and whatever we are evolved and action taken place, that will be given to the current action. What will do like this, if I do, what is the action what I should take? So this will be given to the action, decision making. This input is given to make a decision. Once decision is made, purely it works on what, how far we are from the goal. So it is goal based, right? So how far we are from the goal, depending on that I have to take the action. Okay, how far we are from the goal, depending on that we have to take the action. For example, we can give you Google Map is an example. Gmap. If you want to visit to some hill station, right, your friends has been already there, you want to visit, you ask your friends how easily I can reach to the hill station, or you can search it in the Google. Google will give you to our same destination, source 1, 2, 3, 3 routes, and you will check for shortest route, which is the shortest route. 3 is a shortest route. Okay, depending on the previous history, what your friend said, and depending on the current situation, what you searched in the Google, you decided to go with the shortest route. That is called as goal-based agent. This will take you to your goal. What is my goal? To reach the hill station. Take you to your goal as early as possible. So this is an example for goal-based agent. Next, what we have is utility-based agent. The agent which are developed having their users as building blocks are called utility based. Utility means it has to be useful. That is called as utility based agent. Utility means what? Utility should be beneficial. It should be useful. That is called as utility based agent. When there are a multiple possible alternatives, then to decide which one is the best is utility based agent. So as I just given you the example, you have a different path to reach your destination. Which one is the best? You have to check which one is the best. So it always choose the action based on the performance of the utility on each state. Each state, when you reach from one state to other state, it will check the performance and it will always choose the optimal path. The utility function maps the state onto the real numbers, which describes the association degree of happiness, whether to reaching that goal, whether the agent is happy or not, happy or unhappy. After reaching that goal, if the agent is unhappy, it will go to one more option, one more way of searching the happiness. It's purely depend on whether it is beneficial, what I am working is beneficial or not. That is called as utility based agent. So you can take the example of GPS. So it will give you one path. You're going on that particular path. uh, you reach to some state, you reach to some destination, some half the way, and then you find that there is a roadblock, there is a strike on the road, right? So at that moment, what is the situation of the agent? What is our situation? It's an unhappy situation. So now this utility based agent, what does it do? It will take one more option, way to be happy, to reach the goal earliest, to reach the goal in an optimal solution. So that is called as utility based. So what we are doing here, same, we have a agent, we have an environment, we have a agent. Agent senses the environment. Once it senses, they check with the current situation, check with the current situation is compared with the previous history, and it will be given the depending on the previous history, it is going to take what it will be like to do action, what action is supposed to take. Once action is decided, how happy will I be by using this action, by performing this action, how happy will I be? That will be such dedicated, depends on the utility. And then what action I should do now to make a agent happy, what action should I do now? So then we have a decision. Now which action will make a agent happy, that action has to be done with the help of actuators. This is all about utility based agents. So for different types of agents, what we have discussed. So this completes your first unit. Thank you.